This is the third energy and work video for Physics C. We're going to be looking at the concept of power. This is like work. It's one of those terms that we use in everyday life, but it has a very specific meaning in physics. What power means in physics is the rate at which a force does work, or the rate of working. dW dt, it's a derivative. If you take the work done by the force and look at how that total work done is changing with time, you get the power. So let's explore a little bit what this means. So it's the time derivative of the force dotted into the displacement. And we know that if you take the derivative of this, we're going to assume that the force is constant in time. So the force comes out the front, and we've got the derivative of displacement. But what is that? Well, that's velocity. So another expression for the power is the dot product of force and velocity. And the unit of power is Newton times meters per second, which is kilogram meters squared per seconds cubed. No, pardon me. Yes, per seconds cubed, which we call the watt. Other units of power are the horsepower, which is about 750 watts. There are some others, but that's the only one you're likely to see in everyday life. In this class, we'll almost entirely work with watts. So here's an example. Suppose that you use a pulley to lift a 10 kilogram box through a distance of 4.5 meters. Your maximum power output is 200 watts, so how much time will it take to do the lifting? Well, if you're going to lift 10 kilograms, 4.5 meters, then the work that you have to do, assuming that constant speed and all that, you'll have to lift it by, so work is 10 kilograms times 9.8 meters per second squared times 4.5 meters. And so the work that you do is 441 joules. Now when it says your maximum power output is 200 watts, that means that you are only capable of doing 200 joules of work in 1 second. So the time is going to be the 441 joules divided by the numbers of joules that you do each second. And that works out to be 2.2 seconds, which is pretty quick. Of course, 200 watts is also a very large power output for a person's arms. Another example, let's say that you're driving your car and the drag force on the car is given by 1.05 times the square of the speed, where V is in meters per second, D is in newtons. Now, if the engine's power is 210 horsepower, which we need to convert to watts, that's 1.6 times 10 to the 5th watts. The question is, what is the car's maximum speed when driving on a flat road? We're assuming here a lot of things, the biggest of which is that there's no friction in any of the wheel bearings and so on. And so we're going to get a number that's probably considerably higher than the top speed of any car. But we're going to work this anyway. So we have power equals force times velocity. Now the force that the engine needs to exert is equal to the drag force. So 1.05 times v squared times v again. So 1.05 v cubed. And so if we want to find the velocity, it's the power divided by 1.05 raised to the 1/3 power. So we have 1.6 times 10 to the 5th newtons, or pardon me, watts, divided by 1.05 cube root and we get 53 meters per second, which is not quite 120 miles an hour. So I guess we did get a reasonable number after all. Power is a relatively simple topic. That's why this video is so short. I'm not going to be checking any particular problems tomorrow, but at this point you should be able to work the entire Chapter 7 problem set.